Given the hypotenuse of a right triangle is one more than twice the length of the shortest leg, the second leg is one less than twice the length of the shortest leg, and we need to find the length of each side. So I think it helps if we start this problem by just sketching a little bit of a little right triangle to illustrate what we're given. So I made this side and the bottom the shortest leg, so let's just call them A, B, and C for now. And we know that in order to solve this problem, we're going to end up using the Pythagorean theorem. But before we can use that to solve, we need to eliminate two of the variables so that we have a one variable equation. So if the hypotenuse is one more than twice the length of the shortest leg, then that means, so I made A the shortest leg. So that means the hypotenuse would be one more than twice the length. So 2 times the shortest leg plus 1. And the second leg, which should B, is 1 less than twice the length of the short leg. So B is 2A minus 1. So from there, I can substitute 2A plus 1 and 2A minus 1 in for C and B in this equation, and then I'll have one variable. So I can write A squared plus 2A minus 1 squared equal to 2A plus 1 squared. And then from here, it's a matter of I need to expand everything on both sides of the equation so that I can set it equal to 0 and solve it, since it's quadratic. So let's just break these up into two parts. 2A minus 1 squared is going to be 2A minus 1 times 2A minus 1. And we can multiply these using FOIL. 2A times 2A is 4A squared. 2A times negative 1 is minus 2A. Negative 1 times 2A is minus 2A again. Negative 1 times negative 1 is positive 1. And then combining like terms gives us 4A squared minus 4A plus 1. And I'll do the same thing for this 2A plus 1 squared. 2A plus 1 times 2A plus 1 is going to be 4A squared plus 2A plus another 2A plus 1, which then becomes 4A squared plus 4A plus 1. So when we expand those, we then get A squared plus 4A squared minus 4A plus 1 equals 4A squared plus 4A plus 1. And like I said, it's a quadratic equation. All these variables are being squared. So all of our methods for solving quadratic equations first rely on setting the equation equal to 0. So I'm going to subtract everything from the right side and move it to the left side. So minus 4A squared and minus 4A minus 1. So when I subtract the 4A squared, that's going to make this part go to 0. And then subtract 4A, subtract 1. So notice the 1's go to 0, and the 4A squareds go to 0. You could have, of course, added a squared plus 4a squared to get 5a squared. You would subtract 4a squared and end up with the same result. So after all this, we get a squared minus 8a is equal to 0. Now this, on the left side, is the easiest kind of factoring problem. Of course, we could use quadratic formula, but being able to recognize that this is easy to factor is going to save you a lot of time and honestly a lot of mistakes, because you don't have to go through the trouble of plugging it into the ugly quadratic formula. Anyway, both of these two terms have a common factor of a, so that means we can factor an a out of this side of the equation. We get a times a minus 8 is equal to 0. And then we can use the zero product property, or split up the two terms, or split up the two factors. So this means either a is equal to 0 or a minus 8 is equal to 0. So then a would equal 8. Now, because we're solving for the length of the side of a right triangle, obviously a cannot be 0. We can't have 0 as a length. So then a equals 8 is the length of the shortest side. And then we said the other two sides were 2a minus 1 and 2a plus 1. So c is 2 times 8 plus 1, which is 17. And b is 2 times 8 minus 1, which is 15. So it is, the side lengths are 8, 17, and 15. All right.